So I had the idea that I'd be able to sort of purify and dry propane, so I could, well, use it as a better quality refrigerant rather than just taking it directly out the cylinder. This here is a solution of potassium hydroxide and water. It's just got about 3 capfuls in it. That works fine. When the propane comes out of that, it's totally odourless. Well, not quite, but it ends up just smelling exactly like pure refrigerant. When I first got this, it hardly had much of a smell, but as I started using it, there's more of a smell now. You can definitely smell it, and when it comes out, as I say, it smells just like pure refrigerant. So this part works fine, but obviously bubbling it through this solution to remove the mercaptan, that's what this is doing, would probably add moisture to it. And I had the idea that I could pass it through silica gel to get rid of that moisture, but it's not working, and I'll show you what happens if we just get this in here. Right, so when I turn this on, lots and lots of gas, hardly anything. The silica gel is actually absorbing all the propane as well, so I don't know why it's doing that. I thought it only absorbed the water and maybe some other things, but yeah, all the propane is disappearing pretty much. Now if I cover up the end of this, the pressure hardly goes up at all. It's all been absorbed, so there's just no pressure building up. But when I put air in it, pressure does build up, so there's no leaks. It's all been absorbed. So I might need to use molecular sieves instead. Oh well, it was a good idea at the time, but silica gel just absolutely eats propane. And molecular sieves, they're incredibly expensive. If this did work, I would have been compressing it into another cylinder, this little one down here, but I'm not sure. I might just, there's maybe not that much moisture going into it, I don't know, but that's not ideal. Right, another observation. The bottle is it's very slightly warm. But I've just noticed that it's not absorbing the propane as much now, and I just ran it for a little while. And this silica gel, it's not changing colour. We'll just grab a little piece of it, and I'll just show you what colour it actually goes. Just a little piece down here, so it's usually orange. So I'll just put it in the water, and then we'll see what it changes to. Well, it kind of just goes a sort of dull colour. So that's how you know it's absorbing moisture, but it's doped with a chemical that reacts to water, I think. So I don't know what the story is with propane, if it would change colour. I'd highly doubt it. So now we are starting to get the propane coming through. So there is quite a lot going in and still not very much coming out. So it's still absorbing it, so I'm just going to wait until I'm getting about as much going in as I'm getting coming out, and then I'll be able to start compressing it. And once I do get to that stage, I'll just test it and make sure it's still absorbing moisture. I don't know if it will absorb moisture if it's full of propane. To stop the beads blocking up the outlet tube, I'm just going to shove some stainless steel wool in there. That looks as if it'll do the trick nicely. So now I think we're finally getting somewhere. The propane coming out the end of this smells just exactly the same as refrigerant grade stuff. There's no trace of the smell at all, so the potassium hydroxide solution is removing the mercaptan. You could also use sodium hydroxide too. And this will work for natural gas. If for whatever reason you need to remove the smell from natural gas, if you want to compress it or whatever to avoid stinking up your oil, then you could do the same. It works brilliantly on natural gas too. I think the solution, once it's used up, once it's absorbed all the mercaptan it can, it just sort of, I think it just goes to a neutral pH, and then you can just add more of whatever sodium hydroxide or potassium hydroxide you want. Okay, this is what is this? It started crackling. It's kind of getting warm. It's have I maybe sprayed water into this by accident somehow? Who knows? I don't know. I must have done. Well, I think it's back to the drawing board with this one. There doesn't seem to be any water in the tube at all. So it's not like it's gotten a squirt of water into it. It's like it's probably become saturated with propane and some funny reactions started. Right, I think I know what's happened. I've not been paying attention, and all that's happened is I've just sucked water in the other end when I was bubbling it through. That's all that's happened. I've just sucked water into it, so I'll have to reactivate this, and then we'll just get more silica gel in this. So yeah, I don't think there's any strange reaction taking place. Well, I have lit it, and it is now giving up the propane. I suppose this is a good idea for some sort of tin can fire. That'd make quite a good stove actually. Propane absorbed into silica gel. Yeah, that is definitely burning. Oh well, one success from one failure, I suppose. You can hardly see the flame. It's like it's just a wave of heat coming off it. Yeah, less than a minute later it's just run out. And as I apply heat to it, the flames get a bit bigger. So I'm just going to heat it gently until it stops. If it starts popping, then I'll take the heat off, because you're only meant to heat them to about 120 degrees C anyway. So we'll just get on with that just now. Right, so I've loaded some new silica gel into it. I'll make sure not to let any water suck back through there. It must have been when I switched it off, and then the tube is still sitting in there. It must have absorbed the propane and created some sort of a vacuum. So I'll be sure not to do that again. And once I've done that, I'll get connected up to the compressor, get it all purged, and then start compressing hopefully purer propane. Well, I've sealed up the end of this, and it's still absolutely eating the propane. I'm just going to have to wait till it stops. So it's under a little bit of pressure, so once the bubbling stops, then I'll know it's full of propane. Then I'll do a test to see if it can still absorb water afterwards. Well, that's that finally coming through with refrigerant now, so, and it smells really clean. There's none of that horrible mercaptan in it, so I'm just going to do a test now to see if the silica gel still absorbs moisture. And yes, it sure does absorb moisture still quite well. So it must be absorbing propane, because silica gel is not like a molecular sieve. It's got got lots of different sizes of pores in it, so some of them might be absorbing the propane and others won't. So maybe the correctly sized pores left over will absorb the water. Right, it's all set up now. I'm ready to begin compressing the cleaned propane into here. So I'm just opening this needle valve to let a reasonable flow through. This process will take quite a while. And I'll be back once that's done, once we've got a decent amount in our gas bottle. And we're getting along nicely, it seems to be working well. The flow rate, it looks quite fast, but it's actually not. When I was transferring propane just directly from the tank into here, just as a test, the high pressure side would get quite warm, but because I'm regulating the flow a bit, there's not going to be as much heat generated. So I made this mistake again, but it does work. I managed to get a little bit in here anyway. You can hear some liquid sloshing around in there, so it did work. All I'm going to do is just try and reactivate the stuff that I've ruined, and then put it back into bottles. So it does work. Potassium hydroxide solution to get rid of the mercaptan, and the silica gel just to get rid of the moisture. That's as simple as that.